Hello everyone, today in this video we'll be discussing the super important questions of IoT. The questions have been taken from the previous papers and the model question paper. And before starting, please do like and subscribe. It has to make more videos like this. So without wasting more time, let's get started. And if you watch this video till the end, easily you can score more than 80% marks. These are the most repeated ones. Okay, so let's get started. The first question is, what is IoT? Write the characteristics of IoT system. Okay, IoT means Internet of Things. This means that whatever the things are present in the world, right, like the devices and everything, all those will be connected via internet. Okay, that is called as Internet of Things, IoT. Okay, now we'll be seeing what is the characteristics of IoT. So the first characteristic is the connectivity. Okay, all the devices can be connected with each other using a Wi-Fi, Bluetooth or cellular networks, okay, to communicate and share data. Second is automation and control. All the things which are done by the humans, that can be automated using IoT. Okay, not all of the things, but most of the things which are automatable. Okay, so that includes collecting and analyzing the data from the sensors and triggering the actions without human intervention. Third is scalability. The devices can be scalable and can be produced in large quantities. Fourth is the real-time data processing. Whatever the data we are getting is the real-time data, and that can be processed for insights. Okay, better insights. Fifth is the intelligence and smart decisions. Okay, so IoT devices make a smart decision based on AI and machine learning. Sixth is security and privacy. IoT devices handle sensitive data and they have robust security mechanisms. Okay, heterogeneity. It interacts with the various different devices from the different domains. Okay, and it is energy efficient, and we can monitor it and manage it remotely. And data collection analysis, it collects large amount of data that can be helpful to derive insights for better decision making. Okay, next is explain the classification of computer networks based on the following parameters with neat diagram. First is connection type. Based on connection type, networks are divided into two categories. First is point to point and second is point to multipoint. By the name itself, we can understand what is point to point. Point to point is between one and another. Okay, but just one link, that is called as point to point, host A to host B. Next is point to multipoint. From one host, there it is connected to multiple hosts. That is called as point to multipoint. Second one is physical topology. There are four basic topologies: star, mesh, and bus and ring. Okay, so what is star topology? In star topology, all the devices will be connected to a central hub, and the disadvantage is that if the central hub goes off, none of the devices can share the data. Okay, and next one is the mesh topology. In mesh topology, what happens? All the devices are connected with each other. Okay, if that's the case, then there will be many more connections required. Okay, that is one disadvantage. Okay, because there will be it is connected to every device, so a lot of connections will be required. That's one disadvantage. Okay, next is bus topology. In bus topology, there will be a single backbone bus which will be having all the data getting transferred from all the devices, and whichever the data is to be received, the data, whichever the device has to receive the data, that will be receiving it. Okay, like that, it is a single line connection. And if the bus fails, none of the data can be transferred. Okay, that is one disadvantage. And in ring topology, all the devices will be connected in a ring. This will send the data to this. If this is not the destination, it will pass the data. If this is not the destination, it will pass the data. It will keep on passing until it reaches the destination. And the thing is, here every device will get to know what the data is. Okay, that's one disadvantage. And here also, if link breaks in between 2 points, none of the data can be transferred between the devices. Okay, so that is one disadvantage. Third one is network reachability. There are four criteria: PAN, which is personal area network; LAN, which is local area network; WAN, which is wide area network; and MAN, which is metropolitan area network. This is a network based on the range. Okay, small range is the personal area network, a bigger range is the local area, then more bigger range is the wide area network, and in between the LAN and WAN comes the metropolitan area network. So let's have a look what are the ranges. Okay, personal area network is just for few centimeters or meters, like the Bluetooth we connect, right? We all know that how much range is the Bluetooth, right? So that much is the range is the PAN. Okay, so you can connect the headphones, wireless speakers, laptops, smartphones, wireless keyboards, and so on. Okay, in a house. Okay, that is the personal area network. Next is the local area network. This is for the whole organization or a building. The data will be accessible between the whole building. Okay, that is the local area network. Next is the wide area network. This can go up to a state or a country. Okay, that is the local area networks. It can be used for the satellite based link with satellite based links. Okay, next is the metropolitan area network. This can be restricted to a city. Okay, for the basic example is the internet service providers which we use. Okay, that is the metropolitan area network. Moving on, we have the third super important question, which is, with the help of a neat block diagram, explain ISO-OSI layered network model. Okay, so this is the ISO-OSI layered network model. There are 7 layers here. Okay, the first one is the physical layer. Okay, physical layer consists of the cables and the wires where the data is getting transferred. In data link layer, we'll be having some protocols which will be connecting the hosts. Okay, host A and host B will be connected in data link layer. Next is the network layer. We'll be deciding which network to go with, IPv4, IPv6. Okay, those kind of things will be decided by the network. Next is the transport layer. Transport will decide what kind of protocol you want to use, like the TCP or the UDP protocol. It should be more secure or not. Okay. Presentation and session layers have some more toppings on it. Okay. It's not much widely used, but it is also present. Okay. Then the last one is the application layer. In the application layer, it is a direct connection between this and this. So the protocols used are HTTP, FTP, SMTP, and mail transfer protocol. All those things. Okay. The direct connection between the host and the another host. Okay. The question can be asked in a different way also, where they can ask, explain the connection between two hosts in OSI model. That also, this is the same diagram you need to make. Okay. So with the explanation is given here, we'll just quickly go through it. The first layer is the physical layer. It is also known as the media layer, and here what happens, the main things are the signal generation, signal transfer, voltages, and the mechanical operations like the wires and all which are present, and the cables will be there, and which network we are using, star, mesh, bus, or ring, and the communication mode, simplex, duplex, or full duplex. Okay. This is one way or two way. Okay. Simple duplex means one way or two way. Next is the data link layer. Here we'll be having the establishment and termination of a connection between two hosts. Okay. And detection of correction of errors during communication. So two things are used here: medium access control, MAC, and logical link control. The third one is the network layer. In the network layer, we'll be having the connection made between different networks. Okay. Either by using the virtual circuit networks, or the task is to include addressing, sequencing of the packets, congestion control, error handling, internetworking. Mainly the network is taken into consideration, and here the data is transferred in the form of packets. Moving on to the fourth one, we have the transport layer. In the transport layer, we'll be choosing which protocol we want, whether losses are accepted or not. If losses are accepted and fast data you want, you can go with UDP, else you have to go with TCP, which will be having a more secure connection. Okay. So those things are utilized in the transport layer, and the data is transferred through a thing called as datagram. Okay. Like here it is packet, here it will be datagram. Session layer is responsible for establishing, connect, controlling, and terminating of communication between network hosts. Okay. That is the main layer of session. And after that comes the presentation layer. It is responsible for data format conversion and encryption. Okay. Next comes the transport layer. In the transport layer, it is the host layer, which is the last layer, and it is directly accessible using an end user. Whatever we access, the mobiles and everything, we access the application layer. Okay. So it is helpful in APIs and the file transfer protocols, emails, and other such communications in this layer. Okay. So the summary also is given here with the examples. You can go through it. Okay. Moving on to the fourth one, we have explained the suitable diagram, IoT planes with respect to complex interdependencies of technologies. Okay, so IoT is made up of four planes. How many planes IoT is made up of? Four planes. Four planes means four layers. First is the service layer, second is local connectivity, third is global connectivity, fourth is processing. Okay, so let's have a look in this diagram. We have to make this diagram. Okay, first comes the services layer. In the services layer, we have the protocols such as the Zigbee, RFID, Bluetooth, LoWPAN, and INSON, Ethernet, Wi-Fi, LoRa, Dash, and cellular. All these are the small networks which are present. Okay, that is will be there. The network part will be there in service layer, as well as the devices which we need to connect. Okay, these two things will be there in the service layer, and above that will be the local connectivity, which is used to connect the local devices using gateway, proxy, router, and switch. And if you want to connect using global devices, it will be data centers, web, remote server, and cloud will be used to connect between data between far locations. And the last layer is the processing layer, which is learning about the algorithms and how it can be improved, and visualizing the data, all those insights which will be generated. Okay, so some theory concepts or theory points are also here. First one is the services and local connectivity layer, which I discussed here, right? The last layer. This is the layer which is services and local connectivity. In service and local connectivity, we will be having the devices including wearable appliances, vehicles, UAVs, and sensors, and the protocols used will be the Zigbee, Bluetooth, and all to connect the devices. Okay, and local connectivity and IoT management. Here what will happen, we'll be using the routers, gateways to merge the traffic, conserve the global IP address. Okay, and it works alongside edge computing. The third one is the global connectivity layer. It will be connecting between the different devices in different locations using web, cloud, and data centers. Last is the processing intelligence layer. It is extracts useful human readable insights, and includes data conversion, pattern recognition, algorithm visualization, all such things. So you got the point, right? So this is the fourth plane of IoT. Okay. Moving on to module 2, we have the first super important question, which is define sensors. Classify the various sensors based on power requirement. Okay, what is a sensor? Sensor is nothing but which senses. Okay, it can measure, quantify, or respond to ambient changes in their environment. Okay, if any change is happening, something is detecting that change, that is called as a sensor. Okay, within the intended zone of their deployment. Now there are different categories of sensor based on power requirement. Okay, if the power required is active, okay, active sensors do not require any power. They will work based on the direct stimuli. For example, a photodiode converts light into electrical impulses without any external circuit or mechanism. Okay, it does not require any extra power. It will convert directly. Okay, that is active sensor. Second is passive sensor. It requires external mechanism to power them up. Okay, for example, it will be the thermostator's resistance. Okay, thermostat resistance can be detected. See, this is the resistance. Okay, how it can be detected? By passing a current in between them and seeing how much heat it has generated. Okay, so that is how it will be working. So here what is required is the passing of electricity. Okay, so that is the passive sensor. The next one is to explain the different characteristics of actuators. Okay, so actuators, there are the different four categories are there. The four main reasons for the selection of actuators: weight, power rating, torque to weight ratio, and stiffness and compliance. Okay, weight means physical weight of the actuators, the if it is heavy or light. Okay, for example, if the heavier actuators are there, it is preferred for industrial applications. Okay, and if lighter weight are there, it can be used for the drones and the portable vehicles and so on. Okay, for the home IoT applications. So first is the weight. What is the weight of actuator, whether it is heavy or low? Okay, lighter. Second is power rating, how much power it requires to means work. Okay, that power rating is important to select the actuator. The third is the torque to weight ratio. Okay, torque to weight ratio means how much force it is required to rotate it. Okay, to move the actuator, how much force is it is required. That thing, if it is a heavier uh, moving part, in that case the torque will be lesser. Okay, it is the reverse. If it is a heavier object, torque required will be lesser. And the last one is stiffness and compliance, how hard it is, and whether it can deform under some conditions or not. Okay, that thing is required, stiffness and compliance. Okay, because it will be, the actuators will be deployed in some conditions where there can be high temperature or some a large amount of forces will be there. So this is also one important concept which is taken into consideration, okay, while deciding the actuator. Moving on to the third important question, we have explained the major considerations influencing the choice of sensors in IoT based sensing solutions. Okay, what is the choice of sensor? Which type of sensor you are going to use? That we will be choosing. Okay, based on some factors. So let's have a look. The first factor which we'll be seeing is the sensing range. That sensor, how much it can sense, whether a large area it can sense or a small area. Based on our requirement, it will be chosen. Okay, for example, camera has a sensing range between tens to meters to hundreds of meters. Okay, and based on the complexity, the cost will increase and you can get a better camera which covers more range. Okay, so it all depends on the need and what is the availability. Okay, second is the accuracy and precision. Whatever the sensor is there, how accurate it is and how precise it is. And it is not always the case that we require the accuracy to very much accurate. Okay, sometimes we require just a range of data. Suppose that we are working with large quantities of data, we need not require how many milligrams are there, right? We just require how many kgs are there. So in that case it will not be required, but in some cases where we are measuring with very small data, milligram plays the most important role. Okay, so that is the accuracy and precision. This is one second factor which we consider while choosing the sensors. Third factor is the energy it consumes. Okay, whether it consumes more energy or less energy. Okay, and the fourth one and the last one is the device size. What is the size of the sensor? It is too bulky, it is heavy to be carried, or if it is to be deployed, it is fine if it is bigger, but if it is to be carried around, it should not be bigger, right? So that is the thing which we see, device size. Okay, moving on to the fourth important question, we have about actuators. What is an actuator and what is its mechanism and the types? Okay, actuator mechanism and its types. What is an actuator? It is a mechanism considered as a machine or system component that can affect the movement or control. Okay, what does actuator do? It will do something, it will do some task. Okay, it will take some action, it will throw an object from here to here. Okay, it will do the tasks. Okay, that is the actuator. So how is the mechanism of actuator? There will be four phases here. First is the monitoring phase. Okay, in monitoring phase the command will come. Okay, what is to be done? Okay, so that monitor will be sending that command to a sensor node. Sensor node will process that command from English or human language to a machine level language, and that command will be sent to the actual motor which does the tasks, and the motor will do the task. Okay, and the task will be performed here. Okay, the same thing you have to explain, and the theory part is also here, you can go through it. Okay, next is the actuator types. There are 7 types of actuators. First is the hydraulic actuator. In hydraulic actuator we work with the liquids. Okay, the incompressible property of the liquids. By using that we can take some actions, okay. Because if the suppose that there is a thing like this, okay, there is a water here, and water is getting pushed from here. So what happens, because of its incompressible nature, the water will rise from here, right? If you push here, it will rise from here. So if it rises from here, we can take that force and do some action, because there is a movement happening here. That movement can be converted to any other type of movement, right? So this type of actuator is the hydraulic actuator, which works with the liquids. If you work with the gases, it is called as pneumatic actuator, okay. The incompressible or the compressible properties of the gases, okay. Pneumatic actuator work with the gases. Third is the electricity. If you work with the electric motors to convert into mechanical energy, that will be electric actuators. The thermal and magnetic actuators, the thermal properties, because of heat we can use, and because of magnetic forces, if we make some work done, that is the thermal or magnetic actuators. The next one is the mechanical actuators. It converts the rotatory motion, okay, the circular motion, it will convert to a linear motion, okay. That is a mechanical actuator. Soft actuator and the shape memory polymers, these both are based on the microscopic level, okay. Very small level, there can be some changes required, okay. In that cases, these two actuators will be used, soft actuator and shape memory actuator. They have some properties. Based on that, based on some input, it will change its properties, okay. Like for example, see, it responds to some external stimulus by changing the shape, and then revert back to the original shape once the affecting stimulus is removed. So based on our input of stimulus or not input of stimulus, we can change the shape, and because of the shape is changing, that shape change force can be applied at some microscopic level to achieve the desired shape or something we want to change, okay. So these two are dealing with the microscopic level, okay. So this is the seventh type of sixth and seventh type of actuators, okay. Moving on to the third module, we have the first one question, which is explain different types of data procured based on the urgency of processing with example. Okay, so how much faster we need the data, based on that there is some categorization. Okay, so there are three categories: very critical, very time critical, and normal. Okay, so very critical means data from the sources such as flight control system, healthcare, and other such sources which need immediate decision support are deemed as very critical. So the transfer of such data should be very fast in the in the range of few milliseconds. Latency should not be there, okay. Next range is the time critical, okay. It is also very important, but not as important as very critical, okay. For example, the data with associated with vehicle traffic and machine system and smart home systems, surveillance systems, and so on, these can tolerate a few seconds in the fall in this category, latency of few seconds, okay. Third one is the normal data. It does not matter if there is latency or not. It can vary from minutes to few hours. Associated with that is the data related to agriculture, environmental monitoring, and others, okay, because these data are just for the documentation purpose, okay. And later on we can take insights from it, okay. It's not urgently required. So these are the three categories of data, okay, based on the urgency, okay. Next is the explain deciding factors for selecting a processor for the design of sensor node in IoT device, okay. Now see, we need a sensor node for what? For IoT devices we need a sensor node, but sensor node has a processor, okay. Now which processor we will select? We will select that processor which size is best, okay. Size is best means based on our criteria for what we want to make an IoT device, the size can be big or small, okay. So based on that we will select the first criteria. Second is based on the energy consumption. Is it energy consuming high or low? Is it rechargeable or not? And what is the cost associated with that? And is the memory more or not? Is it volatile, non-volatile? That means if that memory will be erased when the device is switched off or not, okay. Those things will be taken into consideration. Processing power, how fast it can process the data. IO rating, input output rating, 3.3 volt or 5 volts. Add-ons, whether it is possible to attach other things to it, okay. And include other devices also along with that, and work along with that. Is it possible or not, okay. So these are the factors we'll consider while selecting a processor for a sensor node for making IoT devices, okay. Moving on, we have the third important question, which is with a neat diagram explain offsite. Offsite is very important concept, okay. First we will explain what is offsite processing topology, okay? Basically what is offsite, okay. After that we'll see what is the considerations, location, and decision. What we'll see, what is considerations, location, and the decision, okay. First we'll see what is offsite processing topology. Offsite processing means it is it can have latencies, okay. Latencies is not a problem here. On site means at the same time the result should come. Okay, and offsite means the result can come with latency also. Okay, due to processing a network latency, it is fine, and it is significantly cheaper than on-site processing topologies. Okay, and the difference is cost is mainly due to the lower demands, because offsite we can have a little more late data. Okay, and it is not sustainable for a large scale deployments, for typical IoT deployments. Okay, and unlike on-site, offsite has few dedicated high processing enabled devices. In on-site many devices will be there, so here only few are there. So what happens is multiple simpler sensor nodes can be borrowed. Okay, which can be borrowed by multiple simpler sensor nodes, so they form a group and find out the answer. Okay, so here it is the group work. Okay, for the offsite. So here multiple nodes can come together to share their processing power in order to collaboratively process the data. Okay, in on-site it is having a single node which has to be process their data at the same point of time. Okay, so offsite and on-site are the two things we use for sensing the data and processing the data. See, whenever some event happens like fire, okay, on-site means the solution should be visible, solution should be devised at the same point of time, but offsite means the solution can be some other place, remote location, and that event data will be sent to that remote processing, and the remote processing will happen there, and then it will be sent back like that. Okay, so the temperature will sense. If there is more temperature, that means there is fire. It will send the data to sensor node. Sensor node will transfer the data to remote processing. Remote processing will analyze the data and suggest the best solution, and the best solution will be applied here. This the solution is being formed from a different place than what event has happened, right? Where event has happened and the solution, these are two different places. That's why it is off-site. Okay, on-site means everything will be there in the same place. Okay, and it will be faster. So some considerations are there for offloading considerations, okay, which need to be considered while deciding upon the offloading type to choose. Okay, first is bandwidth. How much data can be transferred? Okay, whatever the event data is being generated, how much it can be transferred to the offsite? Okay, that is first thing we'll consider. It is more or less. Second is how much latency can be accepted. Unlimited latency cannot be accepted, right? We need some limit for that. Okay, and criticality, how much it is critical, that much should be the less latency. Means more important data should be more faster. Okay, resources, what are the resources it consumes, and what is the data volume generated that can be used. Okay, so these are the top slide of site considerations. Next, location, where should the solutions be stored at? Okay, first is edge means wherever it is happening the event, there only we will store it. Okay, that is called as edge. Okay, second is fog is stored between the cloud and the place where it is happening. Okay, in between it will be stored. Okay, that will reduce the latencies and the network bandwidth usage. Okay, third is the remote server. It will be stored in some other offsite location. Okay, that is remote server. And cloud means it is accessible throughout the globe. Okay, it will be stored in different servers and it can be accessed anywhere from the earth. Okay, so that is the offload locations. Four types are there. Then comes the offload decision making. Decision making means how much data is to be uploaded and where the data is to be offloaded. Okay, two concepts: where to offload and how much to offload. First is the naive approach. Naive approach means whatever the data is there, offload it to the nearest server. Okay, but that is not applicable in complex data. Second is bargaining based approach. Here we will push it to the nearest one only, but we will also not compromise in the quality also should be maintained. The quality of service and bandwidth, latencies and others should be minimized. The traffic should not be there. Based on these considerations, we will put the data in some server. That is called as the bargaining based approach. The last one is the learning based approach. Learning means we will deploy to many different random servers, and we will be seeing which is giving us the best result and least time amount of time. That one we will be choosing. That is the learning based approach. Okay, based on the feedbacks we will be choosing the data. Moving on to the module 4, we have what is virtualization. Explain the advantages of virtualization. Virtualization means making it a virtual thing. Okay, like key concept of cloud computing. It is a key concept of cloud computing. Technique of sharing a single resource among multiple end user organizations is known as virtualization. So resource is single, but its copies will be made virtual, and that will be given to different organizations. Resource is single, but its copies are made virtual and given to different organizations. That is called as virtualization. Okay, what are the advantages of virtualization? Mainly two key players are here. First is the end user and second is the CSP. This is the industries and these are the humans which are the end users like us. Okay, so advantages for both of them it is there. Okay, like what is advantage for us having the virtual data? Okay, what is advantage is that variety. If virtual data is present, we can have different kinds of virtual data without even purchasing them, because it is coming from different places and all will be visible within our reach. Okay, we'll be having variety of different platforms you can use virtually. Okay, need not to have that virtual system them downloaded in our system. Okay, so we can access it virtually only. Availability means since there are many different copies of it, if this is not available, we can have another copy anytime. Okay, so availability will also be there. Portability means we can access these things from anywhere in the world. Okay, because it is virtual, it is not the physical one, we can access it from anywhere in the world. And elasticity means how we can utilize how much we want. Okay, it's not like you have to buy everything and you'll be using little only and then others will be wasted. How much you want, you will be paying for that. Okay, that is another advantage for the end user. For the CSP or the industries, what are the end users is that resource utilization. The resources which are there gets utilized in multiple exponents. Why? Because it has copies. Okay, and at the same point of time, this copy can be generated and used simultaneously, and the revenue will also be more. Okay, and effective revenue generation, many people use it, and this can be given for other people also to use at the same time, or if after the person has used it, it can be reused by another person, and that will also generate revenue. So revenue wise, it is advantages for the CSP or the industries. Okay, next is explain the importance and metrics. Two things we have to explain: importance and metrics of SLA, service level agreement. Service level agreement is nothing but the terms and conditions. Okay, while we are using the cloud computing, there are some terms and conditions both users and the companies have to accept it. Why it is important? It is important because customers will have their own expectation, like I want this, that, and all, but the organization will say we cannot give that, so there will be a fight in between the customer and the company. So to avoid that, there should be one single document which will have all those things: what is the customer point of view, what is the CSP point of view, and both should agree before using. Next is metrics for SLA. Based on what you will decide the criteria. First is what will be the availability. This metric signifies amount of time service will be accessible. Response time means how much time it will take for a company to respond to a customer. Third is portability, whether it is able to transfer the data from one device to another device or not. And fourth is the problem reporting. Can we report a problem or not? And penalty means if the company does not meet the criteria, what will be the penalty company has to pay to the user. Okay, moving on to the third small question, we have summarized the case study related to smart irrigation management system. Okay, smart irrigation management system. What is irrigation? Irrigation means soil will be there and water will be there, seeds will be there. We are planting it and the trees will be growing. Okay, and to monitor it, it is important. Why we want to monitor these things? Because see, if water level becomes more, in that case, what will happen? The growth of the crops can be bad. See, excess water supply in the agriculture field can damage the crop, so we need to keep an eye on how much water supply is there. Also, insufficient water supply in the agriculture field can also affect the healthy growth of the crops. Okay, so therefore efficient and optimized water supply should be given. Like that, it is true for the soil also, what kind of soil it is and what seeds are being put inside that. Okay, so all those things need to be managed without human intervention. Automatically it should happen based on smart sensors. The sensors will sense what is the level of water. It will sense if the soil is healthy or not. It will sense if any nutrients are required or not, and it will inform the user, so user will do those things. Okay, so it will manage all the irrigation parts. Okay, it is smart irrigation management system. This was developed by IIT Kharagpur. Okay, so architecture includes three layers. First is the sensing layer, second is the remote processing layer, and third is the application layer. First it will sense what is wrong with it. Next it will process what can be done for it, and it will inform the user, and the user in the application layer will make that decision. Okay, so the diagram which you have to make is this. Here sensing will happen. See, there are different sensors: cluster head, processing board, soil moisture sensor, water level sensor, and server will be here. Okay, and the server data will be transferred to the web or mobile device. Okay, so see, sensing and actuating layer will have the protocols associated with the sensing the soil moisture and the water level. Okay, processing and service layer will have the sensing algorithms based on is it right or not, and what can be done for that. What are the solutions present? That will be happening in the processing and service layer. In the application layer, the status will be sent to the cellular phone so that the user can take some action, whether what is to be done. The water is to be put more or less, or soil is to be changed, or some other location it has to be moved to. If sunlight is not coming only in that location, that has to be changed. So that will be done in the application layer. Okay, moving on to the fourth supplement question, we have with an E diagram explain components of agricultural IoT. Okay, so in agricultural IoT, there are few components here. Let's have a look at each of these. Is there a diagram you need to make? Agricultural IoT, what are the things we need? First is the cloud computing we need. Why we need cloud computing? Whatever the data we are getting, that one we have to store it, and we have to analyze that data. For that, storage is required, and the cloud computing is the best storage. Okay, next is the sensors. Sensors we require for sensing what is the level of soil moisture, humidity, water level, temperature, all those things sensors are required. So in agricultural IoT, second thing which is required is the sensors. Third is the camera to capture the images of the soil and everything, and how much plant is growing. Satellite images also help to analyze in a larger scale what's happening. Analytics is important because we want to know the insights of what best decision can be taken based on the insights learned from the previous results. And wireless connectivity, there should be wireless connectivity. Handheld devices for handling remotely. Drone should be there to capture the images from sky view and all. Okay, so it can be able to also spread the pesticides and spraying irrigation, and also it can throw the waters and the seeds. It can distribute evenly. For that we require drones also. Okay, so these are the different components of IoT, agricultural IoT. Moving on to the next one, we have with a neat diagram explaining the architecture of sensor cloud platform. Okay, sensor cloud platform. This is a same cloud platform only, but sensors are included in it. Okay, so the layers are three layers are there. End user layers. Okay, end users are the ones who are using it, and they will be having a web interface through which they will be accessing the cloud. And along with the cloud data, there will be sensor data also, which will be getting inserted into the cloud. And these are the sensor owners who handle this data. And the whole management is done by the SCSP. Okay, which are the managements of sensor cloud platform. Okay, so a few key points for each of these actors in the sensor cloud architecture. First actor is the end user, known as the customer of the cloud sensor cloud services. Okay, he or she registers himself or herself and then uses a template and accesses the web and receive the services which is required. Okay, and sensor owner will sell these services and handle these services, and the entire management responsibility is given to the sensor cloud service provider, responsible for managing the entire sensor cloud infrastructure. Okay, I'm going to 6 question. We have in detail explained the different cloud models with example. Okay, so cloud model, there are mainly two types are there: service model and deployment model. Which are there? Service and deployment model. Okay, service model will include software as a service, platform as a service, infrastructure as a service, and deployment model will have private cloud, community cloud, public cloud, and hybrid cloud. Okay, so what is software as a service? Software as a service means we'll be having a software which we can use. Okay, like for example, Microsoft 365 based on license. Okay, this is a service, right? We can use it based on license. That type is called as software as a service. Second is platform as a service. Like for example, Google App Engine. This is a platform which we can use in the cloud. Okay, so the platform is given as a service. Third is the infrastructure as a service. The whole infrastructure is given. For example, Google Compute Engine. This is a whole infrastructure. Okay, and users can utilize the resources, and that is called as infrastructure as a service. Next one is the deployment model. Here we have a private cloud, which is just for a community or end user organization, maintained privately. Okay, and community cloud is collaboration of different communities, and for each community there is an organization for some shared interests. Okay, like they all want to make food data. Okay, they want to collect food data, so they will have a community cloud for food. Next is public cloud. Public cloud is accessible for everyone. Okay, the service of this cloud is available for any users on the payment basis. And last one is the hybrid cloud. This comprises of two more clouds: private, public, or community. It is a combination of two or more clouds. Okay, moving on to the module 5, we have explained the architecture of vehicular IoT and explain the components used in vehicular IoT. Two things you have to explain. First is the architecture, second is the components used. Okay, so vehicular IoT means in the vehicles, right? The car and all which we drive, in that some sensors are present. Okay, what are those sensors? We'll have a look at it. Okay, so before that, let's have a look at the architecture of vehicular IoT. There are three layers in that. Okay, the first layer is the device layer. Device layer will have all those things which are required for internal environmental sensing, external environment sensing, and data collection and sharing, and event triggering. So those sensors are present. We'll have a look what those sensors are after this diagram. Okay, next is the fog layer. Fog layer will have the low end processing, small scale analytics, short term storage, and decision making in near the devices. This is a lower level of processing. Higher level of processing happens in the cloud, which includes higher end processing, heavy analytics, long term storage, and decision making. Okay, now let's have a look at each layer. What is there? The devices at the bottommost layer which gather the information of the vehicle from inside and the outside, that is called the devices. Okay, next is fog. Fog has fast decision making process, like a cache it is. Okay, in between the device layer and the cloud layer, if you want some small decision to be made, we will not send it to cloud, we'll do it in fog itself. Okay, these are having a lower ended processing systems. Okay, Last is the cloud, which has the actual high-end processing system and large storage of data. Okay, now let's have a look at the components of vehicular IoT. What different types of components are there? Okay, so this is a diagram you need to make for the vehicular IoT, and the first one is the sensors. There are two types of sensors: internal and external. Internal means it will monitor the GPS, fuel levels, proximity, acceleration, pressure, and temperature. External sensor will detect the outside conditions, like for example traffic monitoring, parking detection, capturing images and videos, example license plate recognition. And the next one is a satellite. Okay, satellite is used for vehicle tracking, crash detection, congestion monitoring, and roadblock identification, because from the sky we can easily able to understand where more traffic is happening. Okay, next is wireless connectivity. To transfer the data we need Wi-Fi, Bluetooth, GSM. And roadside units are for sensors for computing devices to process data locally, and facilitates vehicle to vehicle and vehicle to infrastructure communication. Okay, both vehicles can communicate with each other, and vehicle to infrastructure can also communicate in roadside units. Next is cloud and fog computing. Fog will handle the lightweight, time sensitive tasks. Cloud will handle the large scale and complex data. Okay, analytics, it plays a key role in predicting traffic conditions, congestion, and other dynamic vehicular. So after getting all the data, we will apply algorithms to find out what are the analytics. Okay, so that we can make the traffic and all more efficient. Similarly, we have the second question, which is with a neat diagram explaining the architecture of healthcare IoT, where IoT is used in healthcare. What are the components used and what are the advantages and risks? Okay, let's have a look at the architecture. Very simple. Here is the human body, the patient body. Sensors are attached here. All the data will be sent to the sensors. From the data, whatever it is measured, and these sensors transfer the data to the analytics system. Okay, so here algorithms will work, and after that, whatever the results getting produced, that will be in the layer 4. Okay, the same thing you have to explain after making this architecture. Okay, after that we have the components in the healthcare IoT. Okay, what are the components present? Okay, so first is the sensors. Okay, what does sensor do? It will include the heart rate monitor, glucose sensor, body temperature. So all those things which are required for the human healthy life, all those things will be measured. What is the levels of it? Okay, that is what the task of sensors. Second is wireless connectivity to transfer the data from one point to another point. Privacy and security, the things such as protection regulations, HIPAA and GDPR. This will ensure that whatever the data is collected, that is secure and not accessible to everyone. That is privacy and security is maintained here. Okay, and analytics is also plays a very crucial role. It's a main component. Because of analytics only we'll get to know what is to be done. If there is any disease, how severe is the disease, what is to be done, how much time before, what is the time we should take the action first. Okay, means how fast we should take the action, which is a surgery. All those answers will be given by analytics. Okay, after it analyzes and applies algorithms on the data we have got. Okay, next comes the cloud and fog computing for storing and processing data in short and long terms. Interface for getting to see the results, and it's a user friendly interface so that we can understand what is the actual situation. Okay, these are the components of healthcare IoT. Next we have advantages and risks of healthcare IoT. First one is the advantage is real time monitoring. We can do everything in real time, and we can do it very faster also, because if the data is coming in real time, we can take the decision at that time only. Okay, and it is lower cost also, because nowadays the IoTs are very largely manufactured, so it is lower cost. Okay, and it also reduces the cost of keeping the nurses and all. Okay, IoT will do it in a very lesser cost than paying the salary to the nurses. Okay, easy management will be there. We can easily track and keep the management using the softwares. Automatic processing, it requires very less time consuming, and it's very fast also, and it's more accurate. Easy record keeping, we can store all the data in the database systems, and it can be globally accessed if we store in the cloud as well. Easy diagnosis, whatever the diagnosis is present, the systems can detect it more better than humans. Okay, because they are advanced algorithms. Okay, AI driven predictive models. But there are risks also. First is loss of connectivity. Everything in IoT depends on internet. If internet is gone, nothing will work. Okay, second is security risks. So whatever the data is there, it should have very strong encryption, otherwise some hackers will hack the data and take the patient data. Okay, third is errors also can happen, and nevertheless how much accurate AI is, it can still have errors. Okay, so that is a risk associated with that. Okay, moving on to the third important question, we have define machine learning and explain the advantages of machine learning. So what is machine learning? It is a field of study that gives computers the ability to learn without explicitly being programmed. Okay, it can learn by itself, by its own actions and feedback. It can learn and become better. That is called as machine learning. What are the advantages of it? There are many advantages we are all aware of. First is a self learner. Machine learning is a empowered, self empowered. It can take feedback and learn itself, and make itself better. And it is time efficient, it's very faster than humans. And also it is self self-guided. It will find out the solutions for itself. Okay, there is a huge amount of data. It will analyze the data and find out the solutions for itself. Okay, it will find out its own path. Okay, it's self-guided. Then next is minimum human interaction required. ML is automatically becoming more and more advanced, and it is doing tasks on its own with minimum human interaction required, so that we can focus on some other tasks. Okay, while the repetitive task and the decision making, everything will be handled by the ML algorithms. Okay, it handles the diverse data from various applications. It handles the data like the industry, healthcare, smart traffic, smart home, etc. Okay, so these are the advantages of ML. Okay, that's all for the video, and please do like and subscribe. It helps me make more videos like this. Don't miss any of these questions. These are the super repeated ones. And thank you so much for watching. I'll see you in the next one.